Yeah,
I'm ready.
Yeah, no, okay.
Roland, over to you.
Okay, and start from the start. It's recording.
Yeah.
Okay. So, hey everyone. Today I'm going to present one of our own papers that was published in the Empirical Software Engineering Journal this year. This paper is an empirical study of developers' discussions about security challenges of different programming languages. So I'd firstly like to acknowledge the co-authors of this paper, Craig, Mansouri, Ali, and Krista. Now, hopefully this will be an interesting and new presentation for you. I want to present this for two main reasons. Firstly, I think it showcases quite a powerful research method for analyzing developer forums, which can really be used for a variety of research topics. Many of you are probably familiar with works that examine Stack Overflow as a data source, and our group CREST already has several papers led by Triet, Mubin, and Roshan that use these data sources. I think they're still very useful resource for deriving qualitative and quantitative insights. And secondly, I believe this paper covers quite an interesting topic that hasn't really seen that much consideration in the software engineering community yet, which is the choice of programming language. So I think everyone here would probably have their own personal preference for a programming language. Me personally, I really like Python as it's pretty simple to use and it's good for machine learning. But there are many other factors that may play a role in when we're selecting our programming language, such as the project requirements, our personal experience, the learning cost, and just the availability of certain packages. But when it comes to security, we found that this was rarely a consideration. And this is a problem as different programming languages offer different packages and support and are built using different paradigms. For instance, type safety indicates whether a language prevents operations between mismatched types or allows type inconsistency. And a language can either perform memory management automatically or put the onus on the user. This would really lead to different security considerations as C and C++ programs are much more prone to buffer overflow attacks, as they can easily have untrapped memory management errors based on the secure coding practices. In this example, for Java, this unsafe code won't compile as it's a strongly typed language with automatic memory management. So it will simply output errors in the compiler, whereas it will compile for C or C++ and result in undefined behavior. While these factors may be known anecdotally, for instance, in my personal experience, whenever we discuss with other security researchers about source code analysis, one of the first things they ask us is what language we consider. There hasn't really been any systematic or empirical evidence yet of the actual impact that programming language can have. So in this study, we aim to illuminate the impacts that the choice of programming language can have on secure software development. And to do so, we investigated the developer knowledge and practices directly. To achieve this, we used two very valuable sources for software development, Stack Overflow and GitHub. And we picked these sources just due to their prevalence for developers. I think we'd probably all be familiar with these sources and use them at some point. Now, each of these sites contains developer discussions. For Stack Overflow uses post questions, and for GitHub, we have the issues that attach to the repositories. By collecting an appropriate data set of the discussions, we can examine the challenges relating to our topic of analysis. And then with this data set, we can derive qualitative insights from the content of the discussions or quantitative insights from the post metadata, such as the upvotes and the time of the post. So for the data collection, our method really involves a three-step process. Firstly, we selected the programming languages for our analysis, which are the 50 most commonly used programming languages on GitHub. Then secondly, we collected posts for each of these programming languages from each source. For Stack Overflow, we can do so through the tags that's attached to each post. And for GitHub, the programming language is indicated for each repository and its associated issues. Then finally, in the third step, we filter these programming language posts down to ones which just contain security content. This is a bit trickier as posts aren't really marked as security and such, so we had to do so by a keyword matching method where we only took posts which contained a significant portion of security keywords and content. Now, this mostly automated method really allows us to collect a very large amount of posts due to the abundance of information in these sources. In total, we considered 50 programming languages and passed millions of GitHub issues and Stack Overflow posts. And then for our later research questions, we restricted this down to just 15 programming languages and hundreds of thousands of posts. Now, our analysis is mostly framed around the different security topics that are discussed in each programming language. As our dataset was too large to identify the topics manually, we used the semi-automated approach of topic modeling to assist us. For those unfamiliar with topic modeling, it's a NLP technique that can be used to automatically discover the natural topics within a text corpora. Importantly, both for this analysis, we wish to compare the actual topics that are being discussed for each programming language. So we used a technique known as balanced LDA, which essentially constructs an individual topic model for each text corpus. So for us, we had 30 topic models as 15 programming languages across 2 sources, and this resulted in 395 individual topics. We then examined all the topics in unison and constructed a taxonomy using bottom-up labeling approach. I've displayed our produced taxonomy here, and I'll go into a bit further detail during the research questions. So there's 6 research questions in total. We first aim to analyze the general security consideration for the different programming languages by the discussion rate. Essentially, how much of a factor is security in each of these programming language communities? So for this research question, we considered all 50 programming languages, which makes the results a bit too large to display on this slide here. But overall, the security discussion had around an average frequency of 1% for both Stack Overflow and GitHub. We found the languages with the highest frequency of security discussion were the shell-based languages. Bash had the highest at 2.6%, and PowerShell was at 1.9%. And then languages which are often used for web development, like PHP and Ruby, also very high rates. The languages with the least security discussion were those commonly used for scientific programming, like R, Julia, and MATLAB. These only had around 1 in 1,000 security posts, which was very small. So our next 3 research questions analyze the actual content of the security discussions so we narrowed this down to just the 15, so that we top 15 programming languages so that we could make more specific insights. Firstly, we considered the actual intent behind the security discussions, why security questions were being asked and the challenges were being faced. And to do so, we manually categorized the posts for each programming language to an existing categorization scheme for Stack Overflow. This categorization scheme essentially has 5 categories of questions that can be asked, and these relate to API usage, discrepancy or unexpected behavior, errors and exceptions, code review and conceptual discussion, and API change and versions. So we categorized each of the posts for each language, and then we examined the standard deviation of the frequency for each category to the average frequency. And anything greater than 2 standard deviations can really be considered as quite statistically significant. So mainly we found an extremely high proportion of code review questions for C, C++, which indicates that these C developers are aware of the security requirements for this language and are very conscientious about it, but require more knowledge support. We also found that the TypeScript issues on GitHub were very often about security updates and improvements, like how to add extra security features. So for our third research question, we consider the topics of discussion from our topic modeling process, what is being discussed. We measured the relative dominance of each topic for each programming language based on the number of posts that pertain to that topic, and that's displayed in this heat map here. So our manual open coding of the topics, we uncovered 6 main categories that they fell under. So these are cryptography, access control, network security, data security, software vulnerabilities, and secure development. So unfortunately, this graph is again a bit too detailed for me to fully unpack here, but mainly secure development resulted to be the most dominant category for most of the languages, which makes sense given the nature of our data sources, which are towards the system developers with coding and development problems. And access control was the second most prominent category on average, which covers topics like login and user credentials. So we acknowledge that this security taxonomy is not the first of its kind. There is existing security theory and a state-of-the-art which attempts to categorize these things, like the cybersecurity body of knowledge and the common weakness enumeration. However, these existing categories, these existing taxonomies are not empirically constructed from the real-world development challenges like ours. We built ours ground up directly from the data and discussions. We're also the first to map these topics to the programming languages, as we've done the previous slides. Okay, so for research question 4, we considered the temporal trends of the topics, whether the amount of discussion increased or decreased over time, where an increase is a green arrow and a decrease is a red arrow. So generally, we saw that the challenges were increasing for most languages, which is seen by the majority of green arrows, except for PHP, which has a few more red arrows. In terms of the major decreasing trends, we found this to be for network security and data security on Stack Overflow for some of the more common programming languages. The biggest increasing trends, the steepest increase, was for the new programming languages like Go, which was made in 2009, TypeScript, which was made in 2012, and Swift in 2014. So these languages all saw a quite sharp and steady increase in security discussion since their introduction. Finally, for our last 2 research questions, we consider the community support available for the security challenges of different programming languages. Firstly, we consider in research question 5 the relative popularity and difficulty of security posts for each language. The popularity is an indication of how readily the posts are received by the community, how readily they're viewed and handled. And the difficulty indicates the amount of required knowledge and labor to overcome the identified issue. So we obtain representative values for these metrics based on a combination of a variety of metadata attributes, which are displayed here, such as the number of views or the time to answer a question, that type of thing. So these graphs show the relative values and rankings of the popularity and difficulty. And interestingly, we actually found quite a discrepancy between the rankings for Stack Overflow and GitHub. For instance, Perl is the most difficult language on GitHub, but the 3rd easiest in Stack Overflow. This discrepancy probably indicates that developers use these data sources differently for different purposes. But mainly we found, again, the web-oriented languages like Java and TypeScript were the most popular on GitHub that had very low difficulty on Stack Overflow. This could be considered quite preferable if the language is very popular, but also easy to resolve. And finally, we consider the actual users behind these discussions. So for each language, we attempted to estimate the relative security expertise of the users in their community. And we estimate this value from a variety of things, mainly drawn from a user's answer performance and their ability to contribute to these communities. So mainly we observed languages often used for mobile development, like Java, Swift, and Objective-C, to have the highest expertise users on GitHub. So to conclude, findings show that languages exhibit varying rates of security discussion, and the categories of security issues and the characteristics in which these security issues are handled by the community. We often speculate that these trends arise from the application domain that the programming language is used for. But in general, this study helps motivate the important consideration of the influence that programming language can have on secure software development. The taxonomy we've uncovered can also be used to guide educational research efforts, and there are many avenues of future work for this study. For instance, we could extend the investigation to examine the actual source code and patches for software vulnerabilities or issues, and we could also consider technology stacks beyond just programming language, such as the frameworks and tools that are used. Thank you. Any questions?
Thank you, Roland, for such an informative presentation. So if anyone have any questions or suggestions for further discussion, please.
Roland, may I ask about how you handle the data? Like, do you keep the offline copy or do you request every time from online, or how do you handle what you store? How do you update it?
Yeah, we kept all the data and we've released it on a GitHub repository. So for the data, we keep the content of the post and the metadata that we use to calculate those metrics that we reported.
Is it some SQL database you prepare, or how do you store them?
Just CSV files. It's pretty large. A lot.
Thank you.
Roland, I mean, you mentioned that the methodology is significant enough and it can have other usage as well. So can you please elaborate on this one a bit more, because there are few people who might be interested in exploring the open source repositories from the programming languages point of view.
Yes, and so really these papers we've seen that use these data sources have come up quite a bit in the past. Just even within our group, Triet has done one for software vulnerabilities. Mubin has done one based on the containerization technology, and Roshan has done one about continuous software integration. So really, it's a very valuable data source, and the topic, you can really make it whatever you want it to be, just based on the real abundance of these information sources. Like really just anything that developers work on and they can discuss, you can find a lot of interesting insights from these data sources. Yeah, that's my opinion.
Okay, thanks. So I do think people should read this paper carefully if they are looking into the mining software repository research. And I'm not limiting this thing to the one mentioned by Roland, because if you have some other angle, the other day we were talking about, for example, technical debt looking into that. So that can also be mined from the repositories in that context if you're working in that area. In the
So
Roland,
yeah.
one more question about the amount of data and performance. If you'd say total how much data you got in your data set, and if you split the time it's required to mine the data to download compared to analyze it, how would you say, like in percentage and minutes?
It definitely took a lot longer to collect. The data mining is pretty intensive due to the API limits. GitHub is very strict on the API limits. I think it's around 100 requests a minute, maybe something like that, which is slow when you're like scraping hundreds of thousands of stuff. So I think the data collection took us a few weeks at least, just run these scripts in the background. And then the analysis was much quicker. The size of the data set did make it take a long time, but it was only a factor of a few hours, maybe a few days.
And how many megabytes are we talking about in total?
I think around 10 gigabytes.
Thanks.
Roland, may I ask a question?
Yeah.
Yeah. As we can see, the observations or the findings are based on raw data, which are accumulated for a long period of time. I think it's from January 2009 to May 2020. So from your point of view, do you think there are some insights that can be generated by using a short time period, like daily or weekly, monthly data that can we generate some insight from there?
That is an interesting angle. I think for this topic, it would be difficult as security and then security for a specific language doesn't result in a huge amount of data per day or even per month. Like if you're not looking at that popular language, the posts can be quite infrequent. But if you're looking at something which is generating more data, there's definitely potential. Like I remember 2 years ago, someone looked at the posts related to COVID on these data sources, and the daily spikes, you could track them to events.
Yeah, thank you. Because I'm thinking because I'm looking some like vulnerabilities because if we search like log4j or something, there are many discussion on the Stack Overflow as well. So I'm thinking in this direction.
Yeah, I think that could be promising.
Yeah.
Continuing this, Roland, as a suggestion, would you think it would be possible to adapt your system of collecting the data and having a dashboard with these spikes in real time? So we see more discussion about certain languages or products or libraries. We sort of know something is going wrong.
Yeah, if as long as you're not hitting the data limits, you can definitely do it real time.
So any further questions or comments?
So hi, Roland. Thank you for the presentation. It's quite informative. So I just have one question about the secure development of the topic. Like when you categorize with topic modeling, then you name the topic, right? So
Yeah.
from the secure development aspect, that how you differentiate this topic as a separate, like secure development, because access control can be part of secure development, or other techniques. So especially what kind of post is under this category?
Yeah, so secure development was really posts which discuss security aspects, but didn't really tie to any really conceptual theory. So the largest subcategory of this was just testing, like using frameworks to test for security flaws or vulnerabilities. And the other things were using like bug reports and patches and that kind of stuff. But it is with the topic models, the posts don't necessarily just relate to one topic only. Like each post relates to multiple topics, a different proportion. So yeah, each post can be a variety of topics.
Thank you.
Okay, so the paper is online, right, Roland?
Yeah, it was
Okay.
published about a month ago.
So the interested readers maybe can read the paper and have a look to have further in-depth knowledge from this paper. So if anyone else do not have any further questions, maybe we can stop the recording in that case. Okay.
Thank you, Roland.
Okay.
Yeah.
Thank you once
Thank you.
again also. I'll stop the recording.